Hi, I'm Serkan from Huawei Turkey R&D Center. I'm working as a field application engineer. So today I'm gonna cover second stage of full stack AI presentation, and I will explain MindStudio, MindX, and MindSpore sections. Let's go to let's start with MindStudio. MindStudio provides one-stop integrated development environment for AI development. That means you can develop your AI model without needing another tool or infrastructure on Ascent AI solutions. I mean, in the previous stages, Kubilay explained ACL and ATC. The MindStudio covers these tools and more. In that way, you can do your development on MindStudio. Let's look at the MindStudio more deeply. As you can see, the table in the MindStudio integrated development environment, model development, operator development, and application development included. You can make with MindSpore. You can make with this using MindSpore, model visualization, compute power testing, IDE local simulation, and debugging. AI applications in no time and allows you extend exciting functions by using plugins. As you can see in the table in this page, it adapts all Ascent full stack solutions, combining it with a user-friendly interface. Another slides we showed the interfaces as well. We can switch to another slide. Okay. Now you can see the whole MindStudio functions. This is MindStudio's functions, and this is combines in three parts. The first line of the part training model development, the second part inference application development, and third part is custom operator development. These tools can usable with these scenarios in MindStudio integrated development environment. And this IDE provides better experience with AI functions or AI applications, because you can able to model evaluation, model training, accuracy tuning, performance tuning, and deep performance tuning with MindStudio integrated development environment. Also, the application development side, tuning interface performance, you can do this applications. Automatic tuning for inference performance, inference accuracy tuning, and offline model conversion. And the ATC model conversion better with this MindStudio GUI. We'll show this ATC conversion too. If we need to take away about it, we can summarize that MindStudio provides multiple deployment modes and supports multiple mainstream operating softwares, facilitating installation and development. Also, a complete operators development process, and including the unit tests, system tests, and TIK operator debugging. It allows to use to develop TBA custom development and AI CPU custom operators based on mainstream frameworks such as TensorFlow, PyTorch, and MindSpore. In addition to these for network model development, MindStudio supports model training based on TensorFlow, PyTorch, and MindSpore. And as I said, model conversion is supported on this integrated development environment too. Also, you can, if you use MindSpore framework, you can use MindInsight tool. The MindInsight tool is a good tool for training visualization. It is visualize every stage of training. You can see your loss functions or training performance like this, or you can see your graph optimizing functions like this, and such of tools like this. It provides it. MindInsight is good tool. Also, script conversion tool. ATC tool. We will, as I said, we will show it after this slide. Model accuracy analyzer, boosting and efficiency of network model porting, analysis and optimization. We can go to another slide. Okay, let's look the MindStudio development process deeply. As you can see on this page, MindStudio enables end-to-end development without doing extra thing outside it. You can able to manage projects, manage SSH connections. For example, if you have a Atlas 3000 inference server, you should need to connect this device with SSH because you don't use this device from your home or from your any place. MindStudio provides this SSH connection easily. You can connect your device and manage your device with using MindStudio. Also, it provides develop applications, develop custom operators, and model converting tools. You can also collect your data analyze and system-wide logs. And also, you can profile your performance metrics in MindStudio with graphical user interface. Lastly, you can control your device, analyze your models, and install and manage Ascent CAN toolkit with MindStudio. Let's look training phase with MindStudio. MindStudio provides training phase 2, and also you can train your models different third-party frameworks or MindSpore framework, which developed by Huawei. You can build your framework, build your model in MindStudio and train your models in MindStudio in TensorFlow, PyTorch, or MindSpore. Okay, let's look. Can we zoom right? Right. Okay.
So this MindStudio, can you install it on Mac and Windows?
Yes, you can install Windows, Mac. I don't.
No,
Sure.
Not on Ubuntu.
just Windows and Linux.
Mac.
Mac not.
Mac not, but on the Ubuntu it works.
Yes.
Do you need to connect it to Ascent or will it work without Ascent?
It works without connect Ascent, but you cannot use model conversion. You can just use model conversion. After that, as I said before, you need to run this model on Ascent device, but you cannot.
As we can see, right side, you can manage your model inputs in training stage, like this guy. We can give our output path, analysis mode, framework, MPU dump path, model file, and ground truth. And we configure these configurations. We can start our training easily with one page. Let's switch. Okay. We talked about ATC before. ATC provides to you convert third-party frameworks models to offline model format for Ascent device inference applications. MindStudio provides ATC conversion graphical user interface for better experience. Let's take a look.
Yeah. Let me zoom in. Actually, it's basically a user interface. It's managed on the background this ATC script, and it puts this output right format like flag as we did before on the my hands-on applications, and it said modified like dash model, put some pads, something like that. But user doesn't see this kind of details, just see this user UI. Yes.
As we see, we can choose our model file, model name and target socket for version, because we can convert our models 910 chips and 310 chips also, for 310 chips or 910 chips. This architecture is different and it is completely good good thing for talking about, because if you convert your model in different chip version, your model can't work with 310 model chip architecture. Also, we configure our model configurations like this. We can click next and we can see like this page. We can configure our AIPP config files in this page. The AIPP config provides us to model pre-processing stages. This AIPP config takes our input image and configures and pre-processing this image and gives the model the pre-processed images or pre-processed data for our image. The last part, our ATC conversion bash script is given us command preview, and we can click finish, and of the finish we should have our offline model. Also, we can copy this ATC command and use command line interface after that. We can take a look MindX too. Basically, MindX aims to close the gap in AI application implementation and enable rapid availability of AI applications. The MindX has three parts: MindX DL, MindX SDK, and MindX Edge. The MindX DL is an Ascent deep learning component that helps users to quickly develop deep learning systems running on Atlas training and inference cards. It provides basic functions such as cluster scheduling, performance test, and model prediction for Ascent AI processors. It also enables orchestration between Huawei MPUs and schedules the task by providing load balance. It helps to recollect and monitoring these container resources. Thereby, we can quickly build a training platform to complete model training, conversion, and compression with MindX DL. Another MindX distribution is MindX SDK. MindX SDK provides some models such MX Manufacture, MX Vision, MX Index, and MX Tuning Kit to help to quickly develop AI applications and deploy AI application by reducing the code volume by 90%. You can write less code with SDK, and you can do same job with old codes with using Mind SDK. And lastly, MindX Edge enables edge cloud collaboration for fast deployment. You can deploy your AI application on edge side, and you can collaborate this model in the cloud side with MindX Edge tool. Let's look deeply MindX DL. I have three examples for MindX DL. MindX DL uses so many different tools and frameworks. We can give examples for three things: cluster scheduling, ONM management, and model protection. For example, cluster scheduling uses Ascent device plugin tool, HCCL controller tool, Volcano tool, and Elastic Agent tool. The Ascent device plugin, based on the Kubernetes device plugin framework, the device discovery, allocation, and health status reporting functions of Ascent AI processors are added so that Kubernetes can manage Ascent AI processor resources with this Ascent device plugin. The HCCL controller The collective communication information on which a training job depends can be automatically generated in the Kubernetes cluster. You don't not need to manually configure the information if you are using KCCL controller. The Volcano basically doing scheduling plugin mechanism and features such as affinity scheduling and fault rescheduling of Ascent AI processors. And Volcano maximize computing performance of the processor with doing this job. The lastly, elastic agent, this component provides functions such as the dying gasp for reasonable training and restoration policy in data parallel and hybrid parallel scenarios. To use dying gasp function, you need to install this component in training and container. The second example is O&M management. For this example, you can use MPU exporter and noded tools, MindX tools for this application. The MPU exporter, a Prometheus ecosystem component. MPU exporter monitors the metrics of Ascent AI processors, resources, and obtains information such as the Ascent AI processor usage, frequency, temperature, voltage, memory, and allocation in containers in real time. The MPU exporter doing this job. The second tool Noded is doing monitoring functions such as heart beating reporting. What's happening in my device like this. The last example is model protection. In this case, the hackers attacking the models, and we should protect our models for these attacks. And MindX DL provides some good toolkits for these protections. The AI guard, it encrypts and decrypts models, and encrypted model is transmitted and stored in chip hard text, and can be directly deployed in the production environment. You can use the chip-hard model for performance inference to ensure the model confidently during transmission and storage. You can be sure my model is going fine if you are using AI Guard tool. CryptoFS provides transparent decryption and model access control functions, and also allows to access chip-hard models without sensing the model decryption process, and gives access control on decrypted models to prevent illegal access. The last one is AI Vault, and the AI Vault manages master keys and pre-shared keys and supports high concurrency and large-scale clusters. When an application accessed a model, it provides a key decryption API for CryptoFS. This part is... Let's look MindX SDK. The MindX SDK separated 4 parts, as I said, MX Manufacture, MX Vision, MX Index, and MX Tuning Kit. The MX Manufacture is designed to run Huawei Atlas, facilitating plugin mix and match and customization. Designed for the manufacturing field, it provides simplified high-performance APIs and tools to enable quality inspection using Ascent AI processors. The second one is MX Vision. This is doing same things, but this is designed for intelligent video analytics and application side. MX Index is developed for open source FAIS framework, providing simplified high performance APIs, and MX Index enables large scale feature retrieval and clustering using Ascent AI processors. The last one is MX Tuning Kit, supports the MindSpore based foundation models with high performance and improves the efficiency of developing and deploying foundation models by providing such as one-click fine-tuning, evaluation, and inference. And we can talk about MindSpore. I'm sorry. MindSpore is a one-stop development designed for AI developers. You can use it on your AI developments on GPU, CPU, and NPU side. Let's take a look MindSpore. As I said before, MindSpore is an AI framework in all scenarios, aiming to achieve easy development, efficient execution, and all scenario coverage. In the table, we can see all coverages too. All scenario coverage means that the framework supports cloud, edge, and device scenarios. That the biggest difference that makes MindSpore stronger than other third-party frameworks. As you can see in the table, it explains whole MindSpore framework with simple submodules from hardware side to software developer tools. On the bottom of table, you can see that MindSpore supports very wide range of devices such as NPUs, GPUs, and CPUs. Also located in cloud, edge, and device side, smart device side. When it comes to multi-domain expansion line at the top of the table, there are model zoo, extent and scientific computing. The model zoo is, as we talked about the inference stage, we need to convert our original models to offline models. And sometimes it is not easy to accepting. Thus, Huawei provides available deep learning algorithm networks, and more developers are welcome to contribute new networks for model zoo. Extend side, the MindSpore expansion package supports new domain scenarios such as GNN, deep probabilistic programming, and reinforcement learning. More developers are expected to contribute and build this library too. MindScience is using the scientific toolkits, has scientific toolkits, and you can look at this scientific toolkits MindSpore site. There is a lot of scientific toolkit kits depends MindSpore also. Also, MindSpore is developer friendly too. MindSpore providing Python-based front-end expression and programming interfaces. In the future, Huawei plans to continue to provide interconnection with third-party front-end systems such as C and C++, and Huawei developed programming language front-end to introduce more third-party ecosystems. Okay, we can choose next slide. Okay, now we are gonna have a look executing process of MindSpore in this table. As we talked previous page, MindSpore supports different series of hardware in device, edge, and cloud scenarios, including Ascend series products and NVIDIA series products. The blue box on the left side, main MindSpore framework, which can be used for data processing, including data sampling, data iteration, and data format conversion, and other data operations. Many debugging and tuning problems may occur during training. Therefore, the MindSpore Insight module visualize debugging and tuning data such as the loss curve, operator execution status, and weight parameter variables. Also facilitating debugging and optimization during training. In addition to this, the simplest scenario to ensure AI security is from the perspective of attack and defense, as I said. For example, attackers inject malicious data in the training phase to affect the inference capability of AI models. Therefore, MindSpore launches the MindSpore Armor for protecting our models. And this module providing AI security mechanism for MindSpore. And it aims to protect AI models by encrypting model, as we talked previous page. And the content about the blue box, is closer to algorithm development users, including the AI algorithm model library ModelZoo, development toolkit MindSpore, and for development toolkit MindSpore dev kit for different fields, and advanced extension library MindSpore extend on the top of the page. Mind Sciences are scientific computing kits in MindSpore extent. It's worth mentioning for MindSpore scientific kit tools, because there is a bunch of scientific kits in MindSpore. You can try this toolkits if you want it. MindSpore is the first to combine scientific computing with deep learning, combine numerical computing with deep learning, and support electromagnetic simulation and drug molecular simulation through deep learning. And you can use these examples in MindStudio, MindSpore framework web page. You can find it all. After the neural network model is trained, you can export the model or load the model that has been trained in MindSpore hub. Then MindDR provides unified IR format for the device and cloud, which defines logical network structures and operator attributes through unified IR, and decouples model files in MindDR format from hardware platforms to implement one-time training and multiple-time deployments. As shown in the figure, the model is exported to different modules through IR to perform inference. Okay, that's go to another. Okay, let's look what MindSpore has offered that different another frameworks. You can see MindSpore provides automatic differentiation, automatic parallelism, automatic optimization, deep graph optimization, pipeline parallelism, device edge cloud collaboration, and distributed architecture on GPU, CPU, and Ascent devices. These features make it stronger and different than the other frameworks. If you have a GPU, you can use MindSpore too, or CPU and NPU. In that way, MindSpore becomes more popular day by day, and community develops rapidly due to being user-friendly. Please have a look in the right side of the page, and you can see Ascent 910 plus MindSpore using MindSpore framework shows better performance than GPU plus TensorFlow on ResNet 50 with ImageNet dataset. It's providing approximately 2x performance, and it looks fine. Okay, time to hands-on. I will show two examples for you. The first example is TensorFlow MNIST training. For this example, the main purpose is classifying the handwriting numbers with deep learning model. We are gonna train LeNet model with using TensorFlow framework on NPU. The second example is online inference example, and we are using FaceNet for this online inference example. The FaceNet depends, main purpose is finding similarity between faces. The FaceNet model detects faces and some points at the face, like ear, nose, or eye points, or mouth points. And we can use these point values for calculating Euclidean distance and cosine distance. After that, we can compare these distances for finding similarity between faces. Okay. If I will join the meeting and I will share my screen. HDMI. You can see my screen, right? Okay. We can go to HQ training page and you can find our examples right here. Inference training. I gonna show training example first. You can choose TensorFlow Lenet on MPU example and you can go to make these instructions for seeing this. Okay.
Make it bigger.
Okay, I can make it bigger. It's fine?
Yeah. Yeah.
Okay.
Go ahead.
Okay. Yeah, empty. I will clone this repository. Okay, we cloned this repository and we can go our examples page. Hands-on, training, and TensorFlow. As you can see, we got three files right here. The instruction page. Firstly, we should load these modules for running this example. We loaded modules. You can check your modules like with this command. Oh, okay. Okay, that looks better. You can check this modules with this command. After that, we should get this dataset with bash command. I prepared a simple dataset script for getting dataset for our directory. You can start this and you get like this folder. After that, we should write our batch script command, sh script, and we should give this. And after this, we are saying go to training server. You have 10 minutes and task and notes informations. You should run MPU SMI info. After that, you should run this script and end of file. That's it. We are saved this our batch script and we should start our and the give 3323. Okay. Okay. It's controlled our MNIST dataset and it is started to training. And we should wait to seeing outputs. Okay, he got out of memory. Okay. So many users right now.
Finish one. It says failed. Out of memory.
Out of memory, yes.
Because
Someone is using training server like 50 minutes.
Jonathan probably might have to kill the job. You're running a job for 50 minutes?
Yeah, and?
Yeah, no one can use the node.
Yeah,
It's fine, it's fine. The script is working. After that, you can try this.
Does it take memory on the accelerator device or memory on the system? Because on the system it says like, okay, 5 out of 128 used. If you look in HTOP, it looks so...
Serkan, you can set device you are using device
Okay.
0 maybe.
Okay,
Maybe change it, but anyway, now it's okay.
The first setting was to run 320 efforts and those without efficient settings.
Okay.
At the time, you didn't know that you couldn't share it.
I can do oversubscription, but I don't know what will happen then.
I'm supposed to wait in the queue, but you have enabled it to share.
Shall I turn it on, the oversubscription? It might come with issues.
No, don't do it. We need at least the.
Does it mean the server reserves resources on the device, or is it about the host memory, the system memory?
Slurm just reserves a node. I do not have.
The whole node?
Yes.
Okay.
I mean, it has 1 terabyte of memory, so I'm not sure why.
Then I was looking at the wrong machine.
Do you want an HTOP of the training? I am allowed to log in directly.
I don't know, maybe he has built it. It's like a lot of
I don't know what you would need to do to. Okay, I know what you need to do to fill out the terabytes of memory, but I don't think these small examples using
Just go above. Just go above, should be there above. When you set it up. Just go above.
Actually, I'm not sure what oversubscription is already.
By default, it will go to 0. I think the code doesn't have it.
We didn't configure the MPU changes.
So, and we will go
So, okay, so it looks like it's already enabled, but everyone who's logging in is using only the first NPU.
Yes. By
So-
default, it uses a first NPU.
Yeah, so I guess you can just modify, like, what's the variable? Is like ACL visible devices or something like this?
Yes, it's a device.
Yeah, and then just write another number, different.
Yeah.
Is that an environment variable?
Sorry?
ATL visible devices?
Yeah.
Yeah.
You can set you can change ID. Like
Okay.
1, 2, maybe
send device, I think, is what I'm seeing from that output. And you can maybe change that.
Device ID is the same device ID is non-beautiful device 0 except device. Yes. Should be. Can you type MPSMI? Can you type MPSMI? Yeah.
It's working right now. Next step.
It's working now?
Yes, yes.
Okay. All right.
Okay, the outputs are like this. It's trained one epoch and the first epoch is looking like this. This is the TensorFlow training in MPU, on MPU. The second example, let's look at it. The second example is online inference example.
How do we know it worked, your training?
What?
How do we know that the training worked?
As I showed, accuracy and epoch, final accuracy scores, final training steps, seconds, everything is looking. We are knowing it's fine. Also, okay. You can check output file. If it works, you should have checkpoint files like this. These are trained models. After that, you should use these checkpoint files and convert or make inference or something if you want everything. Okay.
All this is done in the TensorFlow. All this is done in the TensorFlow directory.
Yeah. We can. I should show the inference example, and this is TensorFlow 2. This is FaceNet example. You should have everything you need for this example, and we are using Atlas inference card.
You might want to change the size here as well.
Okay, that's fine.
Yeah.
Right.
Yeah, thanks.
As I said, FaceNet is finding the similarities, different faces, and we can make this example following these instructions. Firstly, you should download this model and let's look. Okay, get model. You should change your directory to models. You don't any model right now, and you should start bash script. It automatically downloads the model and extracts for you. We should use PB model because we are making online inference. We have a model file. After that, the instruction says load these modules. Okay, we are gonna load these modules. After that, we should write batch script, but I actually added this batch script to repository. You don't need to write this again. You only step this step, and let's look. These are for warnings from TensorFlow version. Okay, that's running. We give 4 and 5 different images to model, and you are waiting. It reduces the image size 160 to 160 with 3 dimensions. And right now it's running. And that's ended. Give our the Euclidean distance values and cosine distance values. If you want to use this cosine distances, compare these distances and compare the faces are similar or not. Let's look the faces too. The first picture, second, fourth. The first picture looks like this. The second looks like this. Third looks like this, and fourth looks like this, and another person right here. And comparing between the images like this. That's it.
Question. They're all images of the same actress?
What?
They're all images of the same actress?
Yeah, the 4 picture is same actor,
different.
one is different.
But if you look at the Euclidean distance,
Yeah.
between
A and N is
3
same.
and 4 is very high. Even it's the same actress images. It's very high.
Yeah. Actually, it's maybe overfitted model, maybe underfitted model. I don't know. We are using pre-trained model.
Just
Okay.
Can you copy and1 and and2 to the same image? Let's see whether it comes. What is the Euclidean distance we get? You understand what I'm saying?
This one and this one.
Yeah.
What I should do?
Yeah. Just copy the same image.
Okay.
2 images are same.
Okay.
Let's see if the distance is. What is the distance? Is.
Okay.
Just copy one of the files to another one.
I should remove AN and 4. I should copy AN and 3 right here. Okay.
Copy to and4.
Okay, move AN 3 to AN 4 and move this to data file. Okay.
I think you lost the base. You lost the 3 file.
No. Right here. Same sizes you can see.
Yeah, that's fine, that's fine. Let's see if it.
And let's run. Zero. It's the same picture.
So the model works.
Okay, if Alper is available, he can show Alper is here or not.